Okay guys, welcome back to video number 3 for chapter 7.2, angle sum and difference. Okay, and I promised you that this one is a little more involved, but it's nothing you can't handle. Okay, you just have to take what you've got and find what they're looking for, knowing what you know. Which you know the unit circle and you know the quadrant quite well. And I'm trying to adjust this and I don't know why it's not adjusting. It's forgive me just a second. Okay, so this is a given and then a find. So they're going to give us some information and then they say, okay, use this to find blah, blah, blah. All right, let's see what we're given. We are given the sine of our alpha angle is 2/3. We are given a cosine of our beta angle equals -1/4. Okay, so we know cosine is negative. We are also given that the angles are in the interval from pi over 2 to pi. Okay, so that tells you, right, pi over 2 is here, pi is here. So we're going to be dealing in quadrant 3. All right, now I'm going to go ahead and write this again right here. Sine of A is 2/3. We need the cosine of A. We don't have that, but since we're using these sum and difference angles, we're going to need that. So I'm making a little spot for him. Same thing over here. We need the sine of B. Okay, we don't know what that is, but we'll find it. And we have the cosine of B is equal to -1/4. And any sketching of any triangles is going to take place in quadrant 2 when we sketch them out. So you're going to have to sketch. Now some of you will be looking for Pythagorean triples and that kind of thing. All right, great, Miss Smith, but what did it have us find? It had us find sine of A plus B, our alpha angle plus our beta angle. All right, that means we're going to need all of these ingredients to make it work, because here is our formula for sine of alpha plus beta. We need the sine of A and the cosine of A, and we need the sine of B and the cosine of B. So we have to find those by drawing our triangles and using the Pythagorean identities. Okay, so first let's go for this guy. All right, well, we're going to be over here in this quadrant, and I'm going to do a teeny triangle. We have the sine. Well, you know that that's y over r, okay? So we know it's y over r, and then we know we're in quadrant 2 because our cosine is negative, and cosine's negative over here. All right, so I'm going to kind of sketch this out, a little bitty triangle, and I'm going to say, okay, my r I know is 3. My y value, which is my numerator here, is 2. So all we have to do is find my x, okay? Because x is going to help us build cosine, right? Because cosine is x over r. So we already have the 3. That's our r. So let's find the x. Well, x is equal to the square root of r squared minus y squared. X is equal to the square root of 3 squared, which is 9, minus 2 squared, which is 4. X is equal to the square root of 5. Okay, so x is radical 5. So radical 5 over 3 is our missing cosine. So the cosine of alpha is square root of 5 over 3. We need to do the same thing for sine of beta. So we have to find the sine of beta. We don't know what it is. We're going to use our handy dandy. All right, we know we're in quadrant 2, right? Okay, we know that cosine is x over r. And we know x is negative. So we know that that's going to be -1 and that's going to be 4, and y we don't know. So we can find it by saying y is equal to the square root of r squared minus x squared. Y is equal to the square root of 4 squared minus -1 squared. So y is equal to 16, 16 minus, well, -1 squared is +1. So y is equal to the square root of 15, and we're going to put him over our r4. So the cosine for, the sine of b, we just found it. Y is going to be radical 15 over our r value of 4. And sine is positive in this quadrant, so it's going to be radical 15 over 4. All right, so we have all of the ingredients for our formula. All right, so I'm going to go to the next page. All right, so all we have to do now is find the sine of alpha plus beta, which are our two angles, right? Okay, so here we go. Okay, this is number 20 continued. Okay, well the formula reads sine of alpha times the cosine of beta plus cosine of alpha times sine of beta. And we have all of that, right? We have all of that listed at the top of our sheet up here. Okay, we have everything we need, these 4 ingredients right here. So I'm just going to input those values where they belong. And I like to just make little parentheses houses. Okay, so that's going to give us 2/3 here. And the cosine of b, we calculated it. It's negative radical 5 over 4. Okay, so it's got to be a negative. Hold on. All right, back up. Pause, 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 pause. Okay, I'm back. I see what I did. All right, so the cosine of beta is negative 1 over 4. The cosine of alpha is negative radical 5 over 3. And the sine of beta is radical 15 over 4. All right, so it's top times top over bottom times bottom. That's going to give us negative 2 over 12. We can simplify in a minute. Okay, plus, right, over here, that's radical negative 5 times 15, so that's going to give us negative radical, that's going to give us 5 times 3, okay, because we want to simplify that radical 12. That means that guy's going to hop out, so 5's going to hop out. So right now we're looking at negative 2 minus 5 radical 3 over, all right, over 12. All right, there's nothing we can simplify there because none of these outer values will simplify with 12. I mean, 2 can, but they all have to be simplifiable with 12 for us to shrink that down. All right, be right back. Okay, there's a second part to this same number 20. There was actually find this and find this. So this was the second part. This is also what they want us to find. Using the same alpha and beta though, now we're just going to use cosine of alpha plus beta. Cosine of alpha plus beta is this formula, cosine A, cosine B minus sine A, sine B. So that's what we're going to use for this second part of number 20. Okay, so looks like we have the following. Cosine of A minus B is equal to okay, so it's going to be cosine A times cosine B, and then this is going to be sine A and sine B. All right, we have all those values already on our previous page. The same 2 angles. All right, now we're just going to use the values for the cosine A minus B formula. All right, negative, so the cosine of A is negative radical 5 over 3. The cosine of B was negative 1/4. And the 2 sine values, okay, negative sine of A was negative 2/3. Okay, over, the next one is sine of B was radical 15 over 4. Okay, so here, top times top over bottom times bottom, that's going to give us positive radical 5 over 12. Plus here, we're going to have, that's negative 2 radical 15 over 12. So we can put them on the same denominator 12 and say it's radical 5 minus 2 radical 15. Okay, no more simplification possible there. So that was the second part. So you know when you see these, you're going to have to find the various values. Okay, I know I'm jumping around, but I'm coming across a couple that I want to make sure that we understand. No, actually, I think we're doing well. All right, let's keep trucking. All right, 21 is identical. Okay, you can do 21. The same exact thing. Check your quadrant and make sure that when you're sketching your triangle, whether it's in the first or the second. All right, that's fine. Let me keep going. All right, here's one I want to do, because I know you're going to see this and you go, ah! All right, it's not that bad. And I'll try to do this and finish this video. All right, if I have a part 4, it's probably going to be geared towards honors, because there's a couple of identities that you're going to have to prove or disprove for honors. You too, though, traditional, y'all have a couple. But you know your identities, and now you know all of these identities. These are also identities, just like that identity sheet I gave you before. All right, I'm going to see if I can't get through this one pretty quick. 22. Find the exact value. Okay, we are given sine. Okay, now we have inverse functions, guys. We know what to do with these, though. Minus the inverse cosine, 1/2. Okay, remember when we're using inverse, first of all, we have restricted areas. So this is going to be restricted from 0 to pi. Remember, those are the restricted areas where cosine is actually a 1-to-1 function. So we have to look if we're going to be in either quadrant 1 or quadrant 2. So just in helping with your SIGNS, okay, your signs, just to know where you are. Okay, so I'm going to rewrite this, and we've got to convert these into actual angles on the unit circle. Well, we know that this is asking where on the unit circle in a restricted area for cosine, okay, is an angle that has a cosine value of 0. Okay, well, if it's got a cosine value of 0, then you know that that's going to be at pi over 2. So that translates into pi over 2. Okay, this says where on the unit circle, given that you have the restricted area here, right, where are you going to find a cosine or an x value of 1/2? Well, the answer to that is at 30 degrees. 30 degrees is 1/2 comma radical 3 over 2. Cosine is your x coordinate, so pi over 3 is the conversion for that, okay? So again, they're inverses. We've done those before. All right, once we have that, we have our alpha and our beta, and then you can simply say, okay, sine of pi over 2 times cosine of pi over 3 minus the cosine of our first angle, which is pi over 2, and times the sine of b. And my b angle is pi over 3. Okay, whoa, that's a 3. All right, that's our alpha and our beta. So now we just have to go, okay, let's find these values and let's multiply them out. Well, the sine of pi over 2 we know is 1. The cosine of pi over 3 is 1/2 minus the cosine of pi over 2 is 0, and the sine at pi over 3 is radical 3 over 2. So really, truly, that's going to turn to 0, so you are simply left with 1/2. All right, I'm going to probably try to make another video